Okay, let's look at the four types of concentrations that we need to be working with, and let's figure out how to convert from one to another. We've used molarity a lot, and we know and love that as the number of moles of solute per liter of solution. And this is kind of nice because when you have a certain molar solution, like a 6 molar solution, you know that when you pour half of it out, you'll know exactly how many molecules you're pouring out, and that's what it's used for. Now, the new one is called molality, and it looks the same. It's still the number of moles of solute, but now on the bottom it's kilogram of solvent. So molarity is moles per liter of solution. Molality is moles per kilogram of solvent. Let me show you the difference. If we look at this solution here, you see this is a 3 molar solution. It was made by taking 3 moles of this solute. See, look at them down here. Don't they look like they're soluting? And after you took the 3 moles, put them in here, you filled this container up with water to the bottom of the meniscus so that you have exactly 1 liter of solution. So it's a 3 molar solution symbolized by a capital M. That means you have 3 moles in 1 liter. But you don't actually have 1 liter of water. You have 1 liter of solution, and remember that the solution is those little critters on the bottom, your moles, plus the water. So you actually have less than 1 liter of water. Now, if we were to make this a molal solution, here's the difference. A molar solution is moles per liter. So let's say we were trying to make a 3 molal solution. That's symbolized by a lowercase m. We would take 3 moles, the same 3 moles as we had before. Put those little guys in here. That guy's on his head. Okay, so that's the 3 moles, right? We'll put that on top. And then we're going to measure out a kilogram of solvent. Well, 1 kilogram equals a liter. So we're going to measure out 1 liter of water. And we're going to pour it in here. And we're going to pour it in here, and we're going to fill it up, and fill it up, and fill it up, and fill it up, fill it up, and finally it's going to go all over the floor. Because this container only holds 1 liter here. And with a molal solution, you have 3 moles plus 1 liter. So it doesn't have enough room. That's the difference between the two solutions. In a molar solution, you have 3 moles in 1 liter of solution. So you add 3 moles, take 3 moles, and then you add water, so you have a total of 1 liter. In a 3 molal solution, you have 3 moles plus 1 kilogram. Okay, so now here's the question. How do you get from one to another? Okay, what if our question was, we have a 3 molar solution of sodium hydroxide. Convert that to molality. Well, we'll need to do a little conversion here. 3 molar means 3 moles per liter of solution. And we need that to say, boy, that's crazy. We need that to say 3 moles per kilogram of water. Well, the top part's good, right? So what we need to do is we need to convert 1 liter of solution to kilograms of water. And the way we're going to do that is by using the density. Let's say the density of this solution is 1.06 grams per milliliter. Okay, that's our connection between volume and mass. So 1 liter is 1,000 milliliters, and there's 1.06 grams for every milliliter. So that means this 3 molar solution means you have 3 moles and a total of 1,060 grams of solution. Now here's the trick. The solution includes the water plus your 3 moles. And if I know how many grams the 3 moles would be, then I could subtract and get the grams of water. So this is sodium hydroxide, which weighs 40 grams per mole, so 3 moles is 120 grams. So if I had 940 grams of water plus 120, that gives me 1,060 grams of solution. So for my molality, I still have 3 moles on the top, but my bottom is 0.94 kilograms. So that's 3 moles over 0.94 kilograms. Okay, that's like 3.1 molal. And it's a lowercase m. Okay, so what about the other 2 units? One of them is mole fraction. Mole fraction means the number of moles of solute over the total moles. Well, we already know there's 3 moles on the top. So now we just need to find the total moles. How do you find the total moles? Well, you have 940 grams of water, so let's divide this by 18, and that'll tell you the number of moles of water. We know there's 3 moles of sodium hydroxide. So 940 divided by 18 is 55.2 moles. So our total moles would be 55.2 plus 3, so it's 58.2. I think that's a wrong number, but you get the drift. So now the mole fraction is actually left as a decimal. 3 divided by the total number of moles, I think it's 0.05 for the mole fraction. Okay, and now the last one, percent by mass. Would be the number of grams of solute for every 100 grams of solution. Now once you have the numbers from the problems above, this is kind of simple. So we have 3 moles, right? 3 moles were in 1,060 grams of solution. And that 3 moles was actually 120 grams. So 120 grams was in 1,060 grams of solution. So how many grams are in 100? Or divide it, multiply it by 100. And I believe it's 11%. So that's that with the 4 concentrations. Molarity is a capital M. That is moles per liter. Molality is a lowercase m. That's moles per kilogram. To convert between one and the other, you have to use the density, because that's the connection between mass and volume. And then you have mole fraction. The symbol for mole fraction is a funny looking X. That's the mole fraction. And that's moles over total moles. In order to get this answer, you're going to need one of the ones on the top, or the density. The moles you see are always the same, but you're going to need the total number of moles. In order to get the total number of moles, you're going to need exactly the number of grams of water and the number of grams of your solute. And to find percent by mass, you just need the density. You can do that with molality if you want. You just need the density. because you're going to need the number of grams, which you're going to use by converting moles, and then per 100 grams of solution. So you'll need the mass of the solution. Okay, that's that. It's kind of sloppy. Sorry. Tomorrow when you come to class, we'll work on converting these from one to another. We'll practice a predicting reactions question, and we'll venture into the world of colligative properties. Now, isn't that a reason why life is good?